Selamat siang. Mengenal PIP Makassar.
Selamat siang. Mengenal Politeknik Ilmu Pelayaran Makassar. Politeknik Ilmu Pelayaran Makassar atau PIP Makassar memiliki 2 kampus. Kampus 1 berada di Tentara Pelajar nomor 173. Kampus 2 berada di Untia, Kecamatan Biringkanaya. Untuk kampus utama seluas 28.000 meter, sedangkan untuk kampus 2 seluas 54 hektar.
Good afternoon, ladies and gentlemen. I am Wida Agreni. It's my honor to be your Master of Ceremony today. As the host of this occasion, I would like to welcome you to the International Conference on Maritime Development ICMaD 2022 in Politeknik Ilmu Pelayaran Makassar, Indonesia. Ladies and gentlemen, this conference, as the annual program of Politeknik Ilmu Pelayaran Makassar, or Makassar Merchant Marine Polytechnic, is one of maritime school under supervised by Human Resource Development Agency, aims to establish scholars and academic community in pursuing national and international issues on maritime education and training. Furthermore, the conference particularly aims to manage challenges of sustainable maritime by risk analysis and innovation in shipping industry. And this conference is also part of celebration 101 anniversary of Politeknik Ilmu Pelayaran Makassar. Politeknik Ilmu Pelayaran Makassar has the honor to present you this international conference, ICMaD 2022. And it's an honor for me to welcome the head of Human Resource Development Agency, Ministry of Transportation, and all of officers from Human Resource Development Agency, the head of Human Resource Development Center for Sea Transportation, the heads, director, chairman, students, cadets, and lecturers, and the members of maritime institutions in Indonesia, invited speaker and moderator who are the expert in maritime affairs, and also we welcome all participants of ICMaD 2022. Ladies and gentlemen, for this moment, let's rise and sing Indonesian anthem, Indonesia Raya. I invite you to stand up. March of Ministry of Transportation. Audiences may be seated. Ladies and gentlemen, next item, invocation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahillazi ja'ala baldatana hazihi Indonesia wa khususan Makassar baldatun thayyibatun wa rabbun rahim. Salatan wa salaman daiman ala nabiyyina Muhammad sallallahu alaihi wasallam wa ala alihi wa ashabihi ajma'in, amma ba'd. Allahumma ya Rabbana, you are the Almighty God. This year, we are celebrating the 101st anniversary of Merchant Marine Polytechnic of Makassar. At this age, there has been so much blessed that you showered onto this institution. Please do not stop blessing us, because in every achievement we reach, in every landmark we built, in every medal we won, and in every prize we received, there is always be your bless. Allahumma ya Rabbana, you are the Almighty God. Today, we are opening the International Conference on Maritime Development with the theme Sustainable Maritime by Risk Analysis and Innovation in Shipping Industry. Bless this activity by showering the Board of Chiefs, Board of Committees, presenters, supporting team, and every person taking a part in this activity with health, fitness, strong will, and of course, prosperity. Let us do our best so we all can make this activity rich, meaningful, beneficial, and contributive in bringing up innovative insights as stepping stones to reach the higher level of marine transportation science. Allahumma ya Rabbana, you are the Almighty God. Bless the big family of BPSDM of the Ministry of Transportation of Indonesia, and especially the big family of Merchant Marine Polytechnic of Makassar with health, fitness, strong will, and prosperity. So we all have positive energy in performing our best for our cadets, officer cadets, our clients, partners, and the most important one, for our motherland, the Republic of Indonesia. Hasbunallahu wa ni'mal wakil, ni'mal maula wa ni'mal nasir, wala hawla wala quwata illa billahil aliyyil azim. Wassalamualaikum warahmatullahi wabarakatuh.
Well, ladies and gentlemen, now we'd like to invite you to see the traditional dancing performance from Sulawesi. Ladies and gentlemen, please welcome Patudu Dancing. Patudu dance is one of traditional dance usually performed for welcoming guests or special guests. This dance is interpreted an expression of gratitude and joy for arrival of the guests. This can be seen from the smile and expressions of the dancers while dancing. by cadets of Politeknik Ilmu Pelayaran Makassar. Ladies and gentlemen, now let me introduce Head of Human Resource Development Agency, Ministry of Transportation, Mr. Dr. Insinyur Joko Sasono, Master of Science. The second is the Head of Human Resource Development Center for Sea Transportation, Mr. Amiruddin, Master Magister, Master Marine Engineer. Director of Politeknik Ilmu Pelayaran Makassar, Mr. Captain Sukino, Master Magister on Transportation Management, Master Marine. Experts in maritime affairs as invited speakers are the Secretary of Human Resource Development Agency on behalf of Human Resource Development Agency, Ministry of Transportation, Mr. Dr. Captain Anthony Arif Priyadi, Master of Science. Mr. Stefanus Rizdianto, Scholar on Applied Science, Master of Art, Directorate General of Sea Transportation, Ministry of Transportation. Mr. Yusuf Nurwijayanto, PhD, National Research and Innovation Agency. Mr. Professor Dr. Omar bin Yaakob, University Technology Malaysia, Malaysia. Mr. Dr. Yuan Chan Liu, University College London, United Kingdom. Mr. Jung Chulbai, Korea Marine Equipment Research Institute, Korea. And the theme of moderators, Mr. Captain Indra Priyatna and me. Ladies and gentlemen, now we are going to listen the report from Director of Politeknik Ilmu Pelayaran Makassar, Mr. Captain Sukino, Master Magister on Transportation Management, Master Marine. Ladies and gentlemen, please welcome Director of Politeknik Ilmu Pelayaran Makassar, Mr. Captain Sukino.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam Om Swastiastu, Namo Buddhaya, salam kebajikan, salam kebangsaan, salam prestasi dan inovasi. Good afternoon, ladies and gentlemen. Best wishes for all of us. The Honorable Head of Human Resources Development Agency, Ministry of Transportation, Secretary of Human Resources Development Agency, Ministry of Transportation as keynote speaker, Head of Human Resources Development Center on Sea Transportation, all invited speaker and moderator, Chairman and member of Politeknik Ilmu Pelayaran Makassar Public Service Supervisor, all participants who are joining the hybrid conference of the International Conference of Maritime Development on this question. Allow us to deliver to report of the ICMaD activity in Polytechnic at Politeknik Ilmu Pelayaran Makassar as follows. 1. Legal authorities. Law of the Republic of Indonesia, number 17 of 2008 about shipping. Law of Republic of Indonesia, number 12 of 2012 about higher education. Second, the object of the International Conference on the Maritime Development is to discuss the sustainable on maritime industry in 3 pillars: economic, social, and environmental as impact of the pandemic COVID-19 and also the war that occurred in Ukraine with its risk at the must be analyzed so the shipping industry can innovate following axis development for supporting economic growth and maritime environmental protection. Third, tema of the International Conference on Maritime Development ICMaD 2022 at Polytechnic Ilmu Pelayaran Makassar. Sustainable Maritime by Risk Analysis and Innovation in Shipping Industry. 4. Our keynote speaker, invite speaker and moderator to the arts. Master Dr. Kapten Antoni Arif Pribadi, MSI, Secretary of Human Resources Development Agency, Ministry of Transportation. Master Profesor Dr. Omar bin Yaakob, University Teknologi, Malaysia. Master Dr. Yang Liu, Universitas College London, United Kingdom. Master Jung Chu Bae, President of the Korean Marine Equipment Research Institute. Master Yusuf Nur Wijayanto, PhD, National Research and Innovation Agency. Master Stepanus Risdianto, SSIT MA, Director General of Sea Transportation, Ministry of Transportation. Kapten Indra Piatna, expert in maritime issues. 5. Public participant of conference are academic and lecture from the state marine communities, domestic and foreign university, and private maritime education in Indonesia. Shipping officer on merchant vessel, vocational school of seafarer, student of diploma maritime program, the lecturer of Polytechnic Ilmu Pelayaran Makassar, practitioner and professional from shipping companies, alumni on board and in shipping companies. Total 500 participants, which has not include the participants who are joining virtual talk the YouTube live streaming. Sixth, hybrid conference is held today on Wednesday, 12 October 2020 at 1 p.m. until 4 p.m. at Kampus Politeknik Ilmu Pelayaran Makassar. That is all my report of this conference. Furthermore, it is an honor to please the head of Human Resources Development Agency to open the International Conference on Maritime Development ICMaD 2022 officially. Thank you. Wassalamualaikum warahmatullahi wabarakatuh and good afternoon. Direktur Politeknik Ilmu Pelayaran Makassar, Sukirno. Terima kasih.
Thank you, Mr. Captain Sukirno. Master Bachelor in Transportation Management, Master Marine, as Director of Polytechnic Ilmu Pelayaran Makassar for the speech. Well, ladies and gentlemen, today we will open the International Conference on Maritime Development ICMaD 2022. We would like to invite Mr. Dr. Insinyur Joko Sasodo, Master of Science, as Head of Human Resource Development Agency, Ministry Transportation, to deliver a welcome speech, and after the speech, please officially open this conference. To Mr. Dr. Insinyur Joko Sasodo, Master of Science, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. May the peace and blessing of Allah be upon you. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan, salam kebangsaan, salam sehat, salam prestasi. Honorable Professor Omar bin Yaakob from University Teknologi Malaysia, Honorable Dr. Yuan Chang Liu from University College London, United Kingdom, Honorable Dr. Jung Chul Bae the President of the Korean Maritime Equipment Research Institute, Korea, Honorable Stefanus Rustianto from Director General Sea Transportation, Ministry of Transportation Indonesia, Honorable Yusuf Nur Wijayanto, PhD, from National Research and Innovation Agency, Honorable Captain Indra Priyatna, expert from Maritime Institute, Honorable officials of the Ministry of Transportation, Honorable Head of Human Resources Development Center of Sea Transportation, Honorable Principal, Head and Director under the Agency of Human Resources Development of Transportation Indonesia, distinguished participants, ladies and gentlemen. First of all, let us praise God Almighty for His blessing that we could gather here attending the International Conference on Maritime Development in year 2022. I am delighted and honored to greet you and to deliver this speech on behalf of the Ministry of Transportation Indonesia. The Ministry of Transportation is honored to host the international conference with the theme Sustainable Maritime by Risk Analysis and Innovation in Shipping Industry. Participants, ladies and gentlemen, I would like to take this opportunity to introduce the Agency of Human Resource Development Agency on Transportation as an institution under the Ministry of Transportation, which is responsible for developing human resources on land transportation, railways, sea transportation, as well as aviation. Under this agency, there are schools or polytechnics which plays the center of excellence for developing and improving the quality of human resources in transportation field. One of these polytechnics is Makassar Merchant Marine Polytechnic that organizes vocational education as well as functional technical education and training in the field of merchant maritime. A campus is a place and center of excellence in producing human resources through education to improve the culture of learning and innovation, which can ignite the growth mindset of the nation's next generation. Therefore, I encourage all the polytechnics to be more adaptive in transforming the curriculum according to national and global needs, as well as adapting to the characteristics prevalent in Indonesia and international seminar. Participants, ladies and gentlemen, reflecting the commitment of the agency, I believe this conference will provide a forum for all parties such as government officers, stakeholders, and academicians to meet and share information as well as exchange of knowledge and also experience in the improvement of smart, sustainable, and safe transportation system. I also believe this conference will provide wide space for lecturers and researchers, especially in the side, to improve at least the quality of research for further contribution to the transportation communities in the future. This international conference has several topics focusing on the development and innovation of the shipping industry in line with the theme of World Maritime Day 2022, New Technologies for Greener Shipping. I also believe that this conference will provide a great opportunity for innovations, especially for transport and sector, to adopt as well as create a better solution from the recent challenges and changes in this globalization and digitalization era. I am confident that by creating opportunities through discovering innovative approaches and contributions from multidisciplinary sectors, academics, researchers, practitioners, and involving industries will give solution for advances in transportation. Participants, ladies and gentlemen, in the situation of the coronavirus disease-19 pandemic, the war in Ukraine, and the issue of global economic recession, we experience the difficulties in developing technology and researches. However, in order to maintain innovation in transportation, researchers and industry experts need to work in harmony for bringing solutions to achieve sustainable transportation for better future. Innovation thinking requires more than just amazing ideas, such as resources, skills, technologies, information, tools, approaches, and many more. However, the most significant aspect is that innovations need the participation of people. Therefore, human development is one of the important elements that required for innovation can be maintained and developed for a better transportation. I do hope through this conference will give us comprehensive understanding in terms of transportation on interconnected aspect between innovation and industry prospects, as well as the impact to people and society in creating simplicity in life. I also wish that all participants can take advantage of this conference to develop valuable networking in order to pursue new ideas and innovations in transportation. Participants, ladies and gentlemen, I would like to extend my sincere thanks to Makassar Marine Polytechnic, supporting parties and institutions for their participation and contributions in this conference. I would also like to express gratitude to the organizing committee for the hard work in preparing the event today. May the conference be successful, stimulating, fruitful, and enjoyable. Finally, by saying Bismillahirrahmanirrahim, I hereby officially declare the opening of the International Conference on Maritime Development year 2022. May God Almighty always provide His guidance to all of us. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om.
Thank you, Mr. Dr. Insinyur Joko Sasono, Master of Science, for opening this conference. Well, ladies and gentlemen, we have reached the main program, the plenary session of the conference. And this session will be conducted by our moderator. He is an expert in maritime affairs. Well, ladies and gentlemen, please welcome Mr. Captain Indra Priyatna. Hello, sir. Good afternoon.
Good afternoon.
Yes, you can see it. Okay, today Mr. Captain Indra Priyatna will be a moderator for this plenary session. How are you today, sir?
I'm fine, thank you. And how are you too?
I'm good. You look so gorgeous and so handsome with this traditional costume, right? Okay, give applause to Mr. Captain Indra Priyatna.
Thank you.
Okay, it's your turn, sir.
Thank you very much, Ms. Winda Anggreni. Ladies and gentlemen, as it has explained briefly by my colleague, Ms. Winda, that in conjunction with the celebration of 100 years and one of age of the Makassar Merchant Marine Polytechnic, or also known as Polytechnic Ilmu Pelayaran Makassar, and to fulfill the obligation of the higher education to conduct international conference for at least once a year, this Polytechnic held this international conference with the themes Sustainable Maritime by Risk Analysis and Innovation in Shipping Industry. This theme, however, will be elaborated by 6 keynote speakers, whilst each keynote speakers will deliver their scientific article or papers in 20 minutes. Allow me to remind you that the presentation will be flexible according to the time schedule and availability of invited keynote speaker. Before the conference starts, allow me to inform all of the invited keynote speakers that your time to deliver presentation is only 20 minutes. And I will remind you at 5 minutes before the termination of your times. I'm very sorry because we have a restriction in time. And then in the end of the conference, we will have a question and answer. That's it. Ladies and gentlemen, let's the conference begin. Suppose the first keynote speakers is Dr. Kapten Antoni Arif Priyadi, MSc, Master of Science, from the Ministry of Transportation, but he is now in South of Korea. I'm not sure whether he is ready or connected with us or not yet. So, allow me to proceed to the second invited keynote speakers. It will be Mr. Stefanus Risdianto, Master of Art. Mr. Stefanus Risdianto, would you kindly join with us on the stage? There, Mr. Antoni is already ready. Just wait a moment. Mr. Antoni, do you there? Are you ready to present your presentation? Sorry, your...
I just prepare my presentation. Just wait a while.
If you are ready, allow me to read your curriculum vitae. Dr. Kapten Antoni Arif Priyadi, Master of Science, obtained his Diploma 3 degree as well as Certificate of Competency of Deck Officers Class 3 in 1995 from Semarang Merchant Marine Polytechnic, and then obtained his Scholar from Merchant Marine Higher Education in Jakarta in 1999, and he obtained his master degree from WMU, or Malmö, Sweden, in 2006, and graduated his doctoral degree from University of Indonesia and Université du Havre, branch, in 2014. His list of work experience is quite long, as he has engaged as the transportation attaché in Indonesian Embassy in Kuala Lumpur, Malaysia, and as a director of sea traffic and transportation at the Directorate General of Sea Transportation. Therefore, allow me to mention his existing title as the Secretary of the Education and Training Agency, the Ministry of Transportation, while his presentation entitled Indonesian Transportation System in Digital Era. Dr. Anthony, the time is yours, please.
Thank you, moderator. How about our voice, our sound there? Is it clear or not? Hello, Captain. Is it clear for you?
Yeah, we can hear you, although it's not so clearly.
Okay.
I'm sorry.
Long distance, yeah, sorry. I'm at the South Korea right now. Okay, let me share my screen. Yeah. Okay, first of all, distinguished ladies and gentlemen, this is the what I will present in International Conference on Maritime Development, ICMaD 2020. Of course, I will present the Indonesian transportation system in digital era. What we have on this presentation actually regarding the how we have what we call by the toll out or C-toll, yeah, and also the how then we have in our portnet as a system for the transportation, especially maritime transportation used by the several government agency.
Arranged by our agent.
Oh, wait a moment.
Yes, yes. Survey. Members go to Georgia. Georgia. You know, IAM. In the USD. Georgia is next to Turkey. Okay. Turkey. It's located next to Georgia. Yeah. Port. It has IAM. You know IAM? No.
Okay. Pakai apa? Pakai apa? Okay. According to the legal foundation of the sea tolls, or we may acknowledge as the toll out a lot of things that we have the legal basis. For instance, we have the president decree, we have the minister decree, and so on. I just let this legal basis, legal foundation of the toll out, and then we come to the wait moment, moderator. I have a little bit technical problem with our presentation. Wait moment. Cap Indra, I have a problem with the presentation. Could someone assist us from there to load of our presentation?
Bu Heni, Is there anyone that could present the file from Dr. Anthony? Or, excuse me, sir, possibly you can tell us orally. I will catch your explanation, and then in the end, I will summarize your presentation, if you wish. Excuse me, your sound is still mute.
Okay, thank you. Thank you very much. Okay. Yeah, again, I'm so sorry. The legal aspect for the toll out, as I mentioned, we start from the president decree, and then we have also minister's decree and so on. The implementation of sea toll out, it actually is to reduce the logistic cost. Of course, a lot of people and so on ask how the cost of logistic could be reduced by the toll out. Yes, because some costs, related to the transportation cost is subsidized by the government using the toll out ship. Yeah, on the slide number 4, big number 4. And also, a lot of things that the logistic will be reduced, the cost. Yeah, because some costs actually is subsidized by the government. For instance, some of the port operation is subsidized by the government and so on. And of course, the toll is only for certain area in the Indonesia, not all of port. That is why the toll is the number is limited. On the next slide, we may say that actually we have on the beginning 2015, page number 5, with 3 ships and 3 routes. Up to now, in 22, we have a lot of things. We have 33 routes, and also with the 32 ships. Yeah, we have modified about the what we call by the private company to join also with the program of sea toll out. On the next page, this is regarding what we call by the cargo carried by the toll out. Of course, year by year, we have increased the number of cargo load by the program of toll out. Of course, every route they have the specialty. There is a route that the cargo is highly increased normally from the area where the fish production is allowed. On the page number 7, this is
Excuse me. It seems that we have a connection problem. Excuse me, Dr. Anthony, we could not hear you. Reconnecting. Still 10 minutes. It's okay. Hello, Dr. Anthony, can you hear me? Dr. Anthony, if you don't mind, may I explain your presentations? Because to be honest, I have already read your presentation beforehand. So before you presented your presentation, I have already read it. So ladies and gentlemen, let us proceed. We will wait until Dr. Anthony ready. Huh? Oh, okay. Actually, he still have 8 minutes to go. Okay, ladies and gentlemen, allow me to summarize his presentation because I have read it last night. Firstly, he presented about legal standing of sea traffic program, which is also known as tol laut in Bahasa, consists of two presidential decrees, at least 3 Ministry of Transportation decrees, and the Director General of Sea Transportation decree. And then secondly, implementation of sea traffic program data within the last 8 years. And the third, the strategy in the implementation of Indonesian Presidential Decree number 27 year 2020 concerning implementation of public service obligations for transportation of goods from and to the underdeveloped area, to remote area, to outermost area and border area of Indonesia. Fourth, National Logistic Ecosystem Management and its action plan, whereas the pilot project conducted at 14 ports and now progressing to the 70 port. Is that correct, Mr. Stefanus? Yeah. Nowadays, we have already conducted the national logistic system within 70 ports in all over Indonesia. Fifth, collaboration among sea transportation stakeholders through Indonesian National Single Window, including carrier sync. And then the sixth, the implementation of INA Portnet data exchange. That's all of his presentation. This is the broad view of how we manage the Indonesian National Single Window in Indonesia. Ladies and gentlemen, allow me to proceed to the second keynote speakers. It will be Mr. Stefanus Risdianto at my right-hand side. He is a Deputy Director of Directorate of Shipping and Seafarers for Marine Pollution Prevention and Ship Safety Management and Environment Protection. The Director General of Sea Transportation, the Ministry of Transportation. Mr. Risdianto was born in Semarang, 20 September 1977, and now live in Bekasi, west of Java. We are neighbor. And then his education, he graduated from the Merchant Marine Polytechnic in Semarang at year 2000, and graduated Magisters of Mandala Indonesia College of Administration Science in 2018. His qualification now is a Port State Control Officers, ISM Code Auditors, Harbor Master Office Class A, Port State Control Officers, and Marine Inspector Class A. His position experience from 2016 until 2019 as a sailing orders and port order section at Port of Tanjung Priok, Jakarta, and then from year 2019 to 2020, Head of Legal Status and Ship Certificate Division at Port of Tanjung Priok, Jakarta, and now he's a Deputy Director for Marine Pollution Prevention and Ships Safety Management and Environment Protection at the Directorate of Marine Safety and Seafarers. His presentation today, however, entitled Sustainable Maritime by Risk Analysis and Innovations in Shipping Industry. Mr. Stefanus, the time is yours, please.
Thank you, moderators, Captain Indra, my senior, distinguished leader, officer from MOT and associated in ministries and entities, distinguished director of PIP Makassar, academies, and all attendants of this conference, distinguished invited speakers. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon and good day to all. It is an honor for me to be here in the event of International Conference on Maritime Development with the theme Sustainability Maritime by Risk Analysis Innovation in Shipping Industry. The time is 20 minutes, very short, Pak Indra. But
I'm very sorry.
I'll try my best to fastening it. My slide, please. Can we go to my slide? Yes, next slide, please. Here we briefly describe the outline of the discussion that will be discussed in the next slides. It consists of 4 topics. Next slide. Yes, the UN Brundtland Commission defined sustainability as meeting the needs of the present without compromising the ability of future generation to meet their own needs. So sustainability is divided into 3 among others. One is economic sustainability or economic efficiency. Second is environmental sustainability or ecological stability. And the third is social sustainability or social equity. Next slide, please. Sea transportation play an important role in Indonesian economic growth because the sea is barrier-free for transportation route because there is no many people travel by sea. That way, ship from freight forwarders will experience a smooth process of picking up and delivering goods. Next slide, please. Indonesia is located in strategic location on the world trade routes, whereas 90% of international trade by sea, of which 40% passes through Indonesia waters, which have potentially caused safety issues and pollution from ship. Next slide, please. Ladies and gentlemen, the following figure is description of the condition of the shipping lanes. Figure A is combination shipping lanes consists of cargo and passenger ship. Figure B is the shipping lane transfer by cargo ship, and the figure C is shipping lane transfer by passenger ship. Next slide. The following picture is an overview of the Indonesian state constellation that Indonesia has 7.8 million kilometer square of judicial area, with each consists of 5.9 million kilometer square of marine judicial area and 1.9 million kilometer square of land and 95,000 of coastline. Indonesia has a strategic shipping lanes and also located between the continent of Asia and Australia. We have about 257 million residents, and from the data above, the Indonesian government has several challenges due to the large number of islands in Indonesia, including disparity and economic growth are not balanced between the western and eastern region of Indonesia. And then connectivity. Many areas that have not been reached, such as outermost area, border area, and area that have not been developed. And also logistic costs, inadequate infrastructure, and cargo imbalance. Economic as well as connectivity areas that are not been reached have a lower financial level compared to areas that covered by shipping lanes. Next slide, please. According to our data from the official website of Directorate of Marine Safety and Seafarer, the number of ships registered in Indonesia as follow. Passenger ship is almost 5,000, fishing vessel is almost 50,000, and cargo ship 44,000. And the total number of Indonesian registered ship is 98,195, with the total GT is more than 53 millions. The table shows the number of each type of ship and grouping based on the size of GT of each ships. Next slide, please. Shipping company data in the period of 2005 and 2022, there is an increase every year, the both of sea transportation and special sea transportation currently. Next slide. To ensure the seaworthiness, in the following we present data of development of the shipping industry in Indonesia. The capacity of shipbuilding industry or reparation can be conducted that the number of shipyard is approximately 250 units with the annual output capacity of 12 millions deadweight tonnage with the utilization of 85% rate, and the almost 200 units of dockyard with the output capacity reach 1 million deadweight tonnage per year with the utilization of 45%. Next slide, please. The following figure is the map of main logistic route strengthening by hub concept that has been explained by previous moderator, Dr. Anthony. In the context of established connectivity between region to improve connectivity performance between region is supporting regional economy. It goes from Belawan, Batam, Jakarta, Patimban, Surabaya, and then Makassar, Bitung, and Sorong as a route hub, and also followed by many feeder hub to other ports as well by yellow mark color. Next slide, please. For sustainability, we have also policy according to the Decree Minister of Transportation number KP 432 2020. It is explained that our plan is as follows. 136 ports serve sea transportation consists of 28 main ports, 165 collecting port, 66 regional feeder port, and 278 local feeder port. Next slide, please. Implementing sustainable transportation system, it cannot be done alone, but requires solid collaboration and cooperation between government and business entities, operator, ministries, and institutions, even with the community. Next slide. Just like I said before, that the concept of sustainability is economic sustainability, social sustainability, and environmental sustainability. The principles of sustainability transportation are accessibility for everyone, and then social equality, environmental sustainability, health and safety, low cost and economical, information, open information, and community participation and transparency. Next. Here is the 17 goals of 5 important pillars. The 5 important pillars for sustainable development goals are people, to end poverty and hunger in all forms and ensure dignity and equality, and then prosperity, to ensure prosperous of fulfilling lives in harmony with nature, peace, foster peaceful, just, and inclusive societies. Partnership is implement the agenda through a solid global partnership for our planet, protect our planet, natural resources, and climate for future generation. Next slide. We have sustainable transport indicator. The economic sustainability indicators are such as transportation efficiency, integration of transportation network system, the impact of road congestion, the transportation infrastructure, development policy. And for environmental sustainability indicators are noise, air pollution, spatial layout, transportation safety, and public health. And also for social sustainability indicators are travel necessities, accident risk, road inventory, road geometric condition, and traffic characteristic. Next slide, please. In it, it describes the target for reducing greenhouse gas emission. Next slide. Indonesia has its nationality determined contribution, or NDC outlines, Indonesia transition to low emission and climate resilient future. For the post-2020 period and beyond, Indonesia plans to increase the target beyond current commitment. Referring to the latest study on GHG emission level, Indonesia has set unconditional target of 29% and conditional target up to 41% compared to business as usual scenario in 2030. Next slide, please. So, as a follow-up of the implementation of those presidential regulations concerning the National Action Plan for Reducing GHG, the Ministry of Transportation has also issued ministerial decree to support this effort in the land, sea, air, and railway subsector. The main focus of activity in the transportation sector is application of energy efficiency, the use of cleaner fuels, increasing the use of new and renewable energy, and developing mass transportation. For DGST, some programs that are conducted are fuel efficiency, ship modernization, eco-port development, port operational management efficiency, and using energy alternative utilization. Next slide, please. Furthermore, to support sea transportation will be discussed the framework of the GHG emission reduction program and sustainability transportation. The way to gain the GHG reduction from the shipping sector can be done by the following action. First is GHG reduction from ship import, and then port decarbonization, and then GHG reduction for transport into or out of the port, or we call hinterland transport. Next slide. The action plan for climate change mitigation of the Ministry of Sea Transportation, which is using technology, are short and safe road or short sea shipping. They use application of in-port net in ship operation management to make the voyage more safe and effective. Harbor, and then second is harbor operational management efficiency. For navigation, add to navigation solar cell, and then using electrification of port loading and unloading equipment, and use of solar cell and LED lights for port facilities. And then improve monitoring of marine environment. And then also there is technology of shipping telecommunication services such as VTS, vessel traffic services, and ship reporting system. We also develop eco-port development or green port. And then for Directorate for Marine and Safety, also maintenance of ship become our concern. And then the latest innovation are using cold ironing, or we call it onshore power supply while the ship is berthing. Next slide, please. Yes, for your information that onshore power supply and commercial port in Indonesia that have been equipped with shore connection, what is OPS? We call OPS is an electrical system to connect the ship that are docked at the dock or berths within the electricity network on land, so as to allow the ship continue to get electricity supply to turn on cooling, heating, lighting, and other equipment. Turn off the ship auxiliary engine during the ship loading and unloading process at the port. And by 2022, we have more than 21 ports that have been equipped with shore connection and go on with more than 58 points on the ports.
Excuse me, Mr. Stefanus, your time is 5 minutes remaining.
Okay, thank you. Next slide, please. And to maintain the sustainability, there is here's the chart about the concept of smart port in the effort of support national logistics, intelligent, and then environmental friendly and integrated transportation. The port is very important to increase socio-economic, efficient and competitive, and energy efficiency. So, and also followed by saving resources, respect the environment. Next slide, please. Now, the implementation of in-port net is at 77 ports as described on this presentation. The function is for ship arrival notification, port entry permit, loading and discharge plan, ship monitoring determination, port clearance, and the last is port waste management system. There is many application on InnoPortNet that can configure, also can be connected to another ministry IT program. Next slide, please. Here's how Indonesian national policy regarding the transportation to be developed by coordinating with another ministry, entities, and also the academies. Next slide. Maybe this is the last slide. That we have also law enforcement. The law enforcement of Shipping Act regulation under can be done by first Indonesian Coast Guard and internal DGST law enforcement officer, and second is Indonesian Navy officer. The third is police or marine police. And the sanction and penalty can be conducted by legal warning, certificate of license to be suspended or freezing, revocation, fine, penalty, and jail. I think that's all. Yes, thank you. That is my presentation. Look forward for any question or any comments. I think my time is...
It's still 3 minutes to go.
Still 3 minutes to go. Thank you. And then I would like to convey our the warm regard from our Directorate General, because he cannot attend here, and also our director who is now at IMO to conduct the R&D for environmental matters, that is glow falling. It is also became of sustainability in environmental care for DGST. Thank you. That's all my presentation. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much, Mr. Stefanus, for your very comprehensive presentation. We could see at least 9 main areas, as they are firstly the ability of future generations, start with the potential of Indonesia's transportation, and then secondly, how to strengthening the main logistic means, the third, national port development plan, and then the fourth, sustainable development goal and sustainable transportation, and then the fifth, 5 pillars of sustainable development goals, and then the sixth about constellation including sea lanes, number of registered vessel and shipping company data, line of logistic with hub concept, and then 7 will be national GHG, greenhouse gas emission reduction policies. The 8th is potential policy plan for climate change mitigation. The 9th is law enforcement at sea. This information give us the big pictures of the development paths in the development of sea transportation sectors in Indonesia. Again, thank you very much indeed. And ladies and gentlemen, let us proceed to the third keynote speakers. Is Mr. Yusuf Nur Wijayanto, PhD from BRIN, National Research and Innovation Agency, the Republic of Indonesia. But first of all, allow me to read his curriculum vitae. But since his curriculum vitae consists of 12 full pages, allow me to summarize as follows. His education start with Diploma Electronic Engineering from Polytechnic Negeri Semarang, Indonesia, graduate in 2001, and then Bachelor of Engineering in Electrical Engineering from Institut Teknologi 10 November Surabaya, 2004, and then graduate from Masters of Engineering Electrical and Engineering, Osaka University, Osaka, Japan, 2010, and then Doctors of Philosophy in Engineering Electrical Engineering, also in Osaka University in Osaka, Japan, 2013. Work experience, may I read only 2 last position. 2021, present senior researchers, Research Center for Electronic and Telecommunication, National Research and Innovation Agency of BRIN, and then now present as Director, Research Centers for Electronic, National Research and Innovation Agency of Indonesia. Furthermore, he got 9 awards, such as Satya Lancana Pembangunan or National Development Award 2022. He also got 3 scholarships and owned 7 interests such as high-resolution sensing and imaging, electronic and telecommunication, and owned 6 patents. Research experience, 15 scientific activities, 5 journal committees, 17 peer review papers, 11 guest lectures, 12, while his lecture experience is at University of Widyatama, Institute of Technology Bandung, University Pelita Harapan, University Jenderal Ahmad Yani, and Telkom University of Bandung. However, his presentation today entitled Research, Innovation and Challenge in Electronic Technology for Maritime Application. Mr. Yusuf Nurwijayanto, the time is yours.
Okay. Thank you very much, Captain Indra. Very nice to meet you again in here. Before last month I think we meet in offline, yeah, in Semarang, and today we meet you in online in this event. It's a great event, I think. Okay. Allow me to share my slide by me. Can you see my slide, Captain Indra?
Yes, we can see clearly. Yes.
Okay.
Very good.
Okay. Thank you very much. Before that, I would like to thanks to the organizer committee, especially for the Captain Sukirno from the director of PIP Makassar, who has invited me in here in the great conference. I think it's very important for us in Indonesia, and also for all of the structure of the Kementerian Perhubungan. Thank you very much also. And dear all, for all distinguished participants, ladies and gentlemen, in here I would like this is an honor for me to introduce of new National Research Innovation Agency in Indonesia. It's called BRIN. Currently, it's Badan Riset Inovasi Nasional, Badan Riset dan Inovasi Nasional di Indonesia, and also our research activity in the shipping and maritime application, especially based on the electronic technology. So in here, I will give the title of the Research and Innovation and Challenge in the Electronic Technology for Maritime Application. Okay. And in the opening remark, we also remind about the human development is the important element in the current change era. So I think today we have the audience participant from the cadet. You are the future for Indonesia, for keep the ocean, keep the sea, and the maritime transportation and anything. Okay. Before first I will try to introduce our new agency. I think you can.
National Research and Innovation Agency,
This is the new
a synergy
agency.
in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Okay, that's all about the National Research and Innovation Agency, or BRIN, and I will try to.
National.
Sorry, this is the structure. Actually, the print structure is belonging of the President of Indonesia, and especially in here we have the research organization, and we have the 8 research organization. One of them is we have the research organization in electronics and informatics. This is our research organization. But another we have also the research organization in energy and manufacture, and maybe important for the maritime is also we have the kebumian and maritime. This is the important for also for the supporting for the maritime sustainability. Okay. Next is the one of our research organization, the research organization of electronic and informatics. This IM2, the Managed Research and Innovation Program on electronic and informatic field for solving problem and frontier activities in application of human welfare and life sustainability. In here, we have the 6 research center. One of them is the Research Center for Electronics, and the Research Center for Telecommunication, Research Center for the Smart Mechatronics, Research Center Data and Information Science, and then the Research Center Artificial Intelligence and Cybersecurity, and finally we have the Research Center Computation. And currently we on the Research Center Electronics. This is the Research Center Electronics belonging of the National Research and Innovation Agency, BRIN Indonesia. I am to establish place for study, research, development, measurement, and implementation of electronic science and technology and its application in many areas, include the maritime and shipping application. So currently we have the 111 research staff, and our motto is towards humanist developed society through electronic science and technologies, and we hope to give the solution significant and green and also sustainability for our product. Okay, in the research center for electronic, we have the research groups. This is our research groups. The first one is the circuit and optoelectronics. And here we focus on the electronic design and optoelectronics. In the previous speaker also concerned about the LED and maybe some anything device about for the support the maritime and the transportation, we can also develop in here. And also we have the advanced photovoltaic functional electronic device. This is like the solar cell. The previous speaker also mentioned about the solar cell in here. And then we have the digital embedded system. And this is about the electronic circuit in detail. And then we have also the research group on the control electronics. And then we have the electronic safety engineering research groups. And we have the advanced network protocol research hub. And especially in here, also we have the navigation and sensing electronics research group for the transportation system like the ADSB and ICE. Maybe I will mention it before. I will mention it later. And finally, we have the biomedical electronics for the supporting the health equipment in Indonesia. Okay, for our research activity, in here we have the cable-based sensing monitoring communication. This is for the tsunami early warning system. We developed the cable-based in the underwater, undersea, and also we have the ICE for the transportation in the sea, and also ADSB for the light transportation and then telemetry. We also developed the ventilator, telemedicine, hemodialysis, ECG, AMG, and robotics. And also we also developed the automated guided vehicle for the positioning system, something like that, for the autonomous vehicle. And we also research on the smart card mobile application, and also the industrial automation IoT, and also the photovoltaic, the solar cell and sensing device. Okay, this is our Indonesian tsunami early warning system, INATWS. INATEWS. This is we developed the optical fiber in the with the many type many methods. The first one is the buoy. We're using the buoy, and also the cable-based tsunami-meter, and also we use the coastal acoustic tomography, and also we have the observation center in Jakarta. Okay, this is in detail for about the inner buoy. We developed the buoy, and with many sensor in here. We can see in here we keep the sensor in the underwater, and we use the cable and make a communication in here, and buoy we keep the satellite with the central for the observation. This is for the buoy, and maybe this is another for the cable-based tsunami meter. This is we use the cable optical fiber from the beach, and we develop the undersea, and for the keep the sensor in here, and the sensor will be receive the tsunami signal and anything, and we can catch this in the base station in here, and we send to the Jakarta using the satellite and IoT, something like that. This is a typical of sensor, and this is the detail system, and this some figure of the graphic of the observation. This is some video. We actually install this cable base in the Labuan Bajo. This is one of our site station about the INA CBT, cable-based tsunami meter. It's already installed, and we can monitoring several signal about the tsunami and maybe pressure and temperature, something like that, in the undersea of around the Labuan Bajo, something like this. This is the something in the video. Okay, I will leave it, and then sorry. This is the another research in the navigation system. Sorry, some part is still in bahasa. So in the navigation system, we need the security and maybe effective, efficient, and also we need some flight electronic navigation, and also the maritime electronic navigation, and also in the future maybe some vehicle monitoring tracking system for the autonomous vehicle also coming. Also, is not forget is the human monitoring tracking system. So in here we need the precision, real time, and easy, and also economies. Okay, this is our product. One of our product that is called the ADSB, Automatic Dependent Surveillance Broadcast. This is for the flight monitoring based on the ADSB, and also we developed the ADSB ground station, and also we developed the vehicle locator, ADSB transmitter, to transmit the ADSB signal from the ground transportation around the bandara and around the airport. And also we combine with this method for the multilateration, mode ACN 1090AS, and also data fusion method, model correlation detection integrated system to HME also, and also the HME system for alerting SMMS, surface movement monitoring system, to avoid the accident in the airport. This product is already collaboration with the PT Inti and also the Angkasa Pura in Indonesia Airport Company. This is a typical photos of our product and in the experiment in the land, the airport. Okay, and next this is the ICE, automatic identification system. We developed the ICE class B Chamar, and the call is Chamar. We give the name is Chamar. This is the typical figure in the black one, this one. And also ICE monitoring, we developed the software program for the monitor the position of the ship and anything. And we developed the SILPI. This is the System Informasi Lokasi Potensi Ikan. So this SILPI is very useful for the nelayan. So we also develop the navigation application, and also we develop also antenna for ICE and using the AX Yagi. So this is we can get the high gain and very sensitive, so we can get the more signal ICE for the long distance, something like that.
Excuse me, sir. Your time
Yes.
is 5 minutes remaining.
Okay, please. Yeah, okay. This product already collaborate with Naficom and also the SD Micro, and already collaboration with the KKP also, and also Kementerian Perhubungan. Okay, this is the typical method of the SILPI. This is we can get the fish location data from the remote sensing from the BROL. This is the Badan Riset Observasi Laut from the KKP, and riset organization of the penerbangan and antariksa BRIN. We analyze the signal and give the server, and then send the cellular. After that, and the nelayan can receive the position of the fish, and easy for the nelayan can catch the fish. This is very important for fishing, something like that. Okay, this is the navigation radar system. We also developed the navigation radar system for the avoid the accident and avoidance, something like that. Okay, this is the additional for the Puna Malay. We also developed some medium altitude long endurance Malay, and we developed the control simulation, GCS manufacture, and the component integration and testing also in it. Okay. Additional for the photovoltaics module cell Soria, we can see we develop also the solar cell in here, and the another alternative for the energy and sensing also we develop for the support for the maritime sensing and imaging. This is for the underwater integrated system. Before we imagine if our two land we connect the optical fiber, and we can get the many sensors here. We can identify underwater, undersea environment. What is the coming in the underwater? Tsunami and the pressure and the fish, and maybe something pesawat asing, something like that, drone we can monitor in here. So this is the remote research session. Actually, the BRIN prepare for 25 station research in Indonesia. One of them is we will put the buoy with the many sensor here. We call it smart buoy. So this is very important also for the monitoring our weather and something like this. Also in the underwater also we also develop. This is for the future. This intelligent transportation system. Sorry, this is some maybe for the autonomous vehicle in the sea.
The ocean, our engineering need to respect the power of what happens out there.
There's still things to be discovered. If we have a zero risk philosophy.
Yeah, this is the IBM.
When we first conceived this idea of a vehicle out in the middle of the Atlantic Ocean.
We built a ship, put autonomy into it, and now we're learning what that means.
Pressure certainly.
Something.
Want to finish shaking her out? Pulls out of Plymouth, and I know it. And failing doesn't bother me. It's if we don't do everything we can do to.
Okay, maybe that's all about our research. Maybe this is additional for the service of the BRIN. I will introduce the BRIN have the open access currently. So we have the many deputy in here. One of them is infrastructure, facility, resource dissemination, and then science human resource. For in the opening, I think it's very interesting also for the Pak Sukirno. This is important for you also for the cadet. This is the research assistant. Actually, we have the many program in here, research assistant, and then bantuan riset TA, and then study by research, researcher mobility, and maybe you know about the MBKM, yeah, Merdeka Belajar. And then we aim about the infrastructure, we can use for the all Indonesian experiment, measurement, certification, and facility. We have the many program for the research and innovation, expedition, and maybe some pusat collaboration research. Also in the dissemination, we have the dissemination and licensing. For detail, maybe you can visit in this website. Okay, maybe that's all for Pak Indra for my presentation. If for the further correspondence, please contact me by email or maybe by WhatsApp, something like this. Okay, thank you very much. I will be back I give back to the Captain Indra. Thank you very much.
Perfect. Exactly 20 minutes. Mr. Yusuf Nurwijayanto, thank you very much indeed for your very comprehensive presentation. Your presentation, however, amongst other things, covers about 9 topics, as there are first organization structures of BRIN, and then secondly, Indonesian Tsunami Early Warning System, the third, navigation system, including navigation radar system, the fourth, automatic dependent surveillance broadcasts, including AIS, automatic identification system, and then the fifth, SILPI, Sistem Informasi Potensi Ikan, or Fish Potensi Information System, and then the sixth about the Puna Mail, 7, underwater integrated sensing system, 8, remote research station and high efficiency photovoltaic devices, and energy and sensing devices, and the last but not least, future technology and the challenges. Thank you very much for your kind presentation. This is good for our input for the review of our curriculum. Ladies and gentlemen, let's us proceed to the fourth keynote speakers. It will be Professor Dr. Omar bin Yaakob from University of Malaysia. Allow me, for the first of all, to read his curriculum vitae, but allow me to make it short. Professor Umar is now a professor in marine technology in the School of Mechanical Engineering, University Technology, Malaysia, and a research fellow at UTM Marine Technology Center. He started his career at University Technology, Malaysia as an assistant lecturer in Department of Thermal Fluid, Faculty of Mechanical Engineering in August 1983. While in this service, he continued his studies and completed a master's degree in marine technology in 1987 as a PhD in seakeeping design in 1999 at the University of Newcastle. He was appointed an associate professor in year 2000 and a professor in 2011. In the early stage of his career at UTM, Professor Umar focused on teaching and research and development in the fields of naval architectures, ship design, hydrodynamic, marine transportation, management and operation. And then in the early 2000s, he moved on to pioneers a new field in Malaysia, ocean renewable energy and marine environment. He acknowledged experience and expertise in the field led to an invitation to represent Malaysia in a forum on ocean renewable energy at the headquarters of the United Nations in New York in 2012. He also represented Malaysia several times at meeting of the World Maritime Organizations on marine environment protection since 2010. He has held the post of head of the Marine Panel, head of the Department of Thermal Fluid, head of the Marine Technology Laboratory, head of the Department of Marine Technology, Deputy Dean, Academic, and the last Deputy Dean, Research and Innovation in 2017. Professor Umar is currently the elected chairman of UTM Professor Council and an elected member of the UTM Senate since 2013. And in April 2019, he was elected as the Senate representative member at the UTM Board Directors. It's very long, may I jump? He has represented Malaysia in many meetings at the International Maritime Organization dealing with energy, efficiency, and the environment. He is one of the founding members of Southeast Asia Collaboration on Ocean Renewable Energy, a member of IOC WESPEC working groups on marine renewable energy, as well as a permanent member of the organizing committee of ASEAN Wave and Tidal Energy Conference Series. However, his presentation entitled International Initiative for Low Carbon Shipping. Professor, the time is yours.
Thank you. Captain Indra, can you hear me? Can you hear me?
Yeah, we can hear you very clearly. Thank you.
All right, so I'll just continue. Thank you very much for that long introduction. I don't expect it to be that long, but thank you to Polytechnic Ilmu Pelayaran Makassar for inviting me. I think we don't have much time, so I'll just straight away go to my presentation. This is the outline of my presentation. It looks like we have a lot to cover. I hope I can cover it within the next 18 minutes or so. I'll cover basically about GHG emission from ships, and then a bit about introduction to maritime implementation. But I'm speaking to the maritime community. Maybe I don't need to spend a long time there. And then I want to focus on mainly sharing on what's happening at the international level in terms of the regulatory structure for mitigating GHG from shipping. Of course, greenhouse gas emissions. It's not only carbon dioxide, but mainly in shipping, we are looking mainly at carbon dioxide. Okay, and then the goals and what are the current mandatory international rules, so that the audience will be up to date with what's happening and how we are preparing for it, either from design and operation of the ships. And finally, we'll share a little bit about how we get energy efficient, low carbon ships, and concluding remarks. Right. First, of course, we want to look at how much the contribution of shipping to the percentage of global carbon dioxide. So we see it's not that much. It's about 3%, less than 3%, according to study in the fourth GHG study 2020. So it's not much. And in fact, shipping is the most efficient in terms of transport. So if transport work, the ton times the kilometer to transport 1 ton of cargo 1 kilometer. If you compare the various like a big tanker down there, big tanker here, big tanker down here, and compare that to the aircraft, is a very big difference. So along the way, of course, we have the trucks and even the rail, but nevertheless, the shipping community still want to do something about it. We are required to do something, and because of the increase in the world shipping, the trade, world trade, yes, and we know more than 80% of international trade goes by sea. So because of that, we need to make sure that with the increasing trade, increasing number of ships and so on, we do not contribute more. In fact, our plan is to reduce, as we see in this green line, the blue line here. Okay, so this is basically the summary. Shipping GHG emission represent less than 3% of global anthropogenic means human-made, GHG emissions. International shipping is expected to grow its volume, and BAU means business as usual. If we don't do anything about it, then we are set to multiply double or triple the amount of carbon dioxide or GHG emission by 2050. Shipping non-GHG emissions are also important contributors to air pollution effects. So the emission from the engines not only has CO2, but also the pollution, the polluters, which has now salts, volatile organic compound, and PM 2.5. And shipping uses lower quality fuel compared to other mode of transport. So we use very dirty, thick fuels. So because of that, we need to try to do something to reduce that. So this is about IMO. As I said, I'm talking to the community, so I'm not going to talk more about this IMO than to show you some these slides. We have 174 member states at the moment. But the main thing about IMO that is related to what the topic of my speech today is about the rules that is developed. Okay, so IMO developed rules using what's called as conventions or protocols, and these are implemented by the flag states. For example, Indonesia is a flag state. All ships registered in Indonesia will carry Indonesian flags, will be subject to the rules, and also the enforcement by the port and coastal state. Even if Indonesian ships want to come to Malaysia, then Malaysia will have a port and state, we call it port state control on the ships that's coming from other places, including Indonesia. So because of that, the implementation of the IMO rules is very universal and enforceable. That means we can enforce the rules. The main rules related to carbon is MAPOL. Of course, we have heard MAPOL many times since 1973. But now, what we're talking about is Chapter 3 and Chapter 4 of MAPOL, of Annex 6, of MAPOL. Yeah. So, and the main one that's related to greenhouse gas emission or carbon reduction is Chapter 4, GHG and energy efficiency. Okay, so I've covered the first two topics. I'll go on to the next topic. The next topic is first mandatory regulation at IMO for mitigating GHG from shipping. So this is the landmark rules or regulation that was decided in July 2011. I was there representing Malaysia, and we had long and heated discussions how we want to reduce this, and we came up with what is called as the greenhouse gas emission amendment to Annex 6, Chapter 4, and that's to be implemented from 2013. And that was the first mandatory global greenhouse gas reduction regime for an international industry sector. They do not have for even aviation or what more for land transport, but we have for shipping. At that time, what was decided was our EEDI. So maybe you have heard about EEDI before this. It was the first implemented in January 2013, and also the SEMP. So EEDI are for the designers, and SEMP are for the operators. So I don't have to go into detail this one. This is a bit old already, 2013, so we should be aware about this. Again, this is the formula. I don't have to go to that. Now, after checking through what has been happening, the records of the EEDI that was submitted throughout the years until 2017, they found that the EEDI of the ships are getting better and better, below than the required here. So because of that, IMO says that, okay, because of this, we can expedite the rules by pulling down the line further, because EEDI needs to be below the line. So if you bring down the standard reference line, then the ships must comply by doing more things to bring the EEDI down. So at this point, for example, the EEDI is about 15 gram carbon dioxide per ton mile. And here the current efficiency of the various ships are also being improved since 2013. That is 58% for containers and so on. Okay, so now we come to the new vision of IMO, basically to cut, to revise the strategy. So this is the initial strategy. So the main goal is to cut greenhouse gas emission from international shipping by at least half by 2050. We did not, IMO did not promise to have zero or net zero, because it is almost impossible. You know the technicalities and so on. It's not possible to get. So we just promised to get half by 2050. And in terms of the intensity, carbon intensity, carbon intensity being CO2 per transport work, we expect to reduce by 20%, by 70%, sorry, by 70%. So we are left with 30% of the current intensity. So this is to be revised next year. The new regulation from November, which is next month, these are the new regulations. Number one will be what is called as EEXI. I think I'll summarize here. This is the summary. From November, in terms of technical, in 2013, it was only EEDI and SEMP. But from November, this will be coming in, which is EEXI and CII, Carbon Intensity Index, CII. Yeah. And also the EEDI will be more strict, as I said, bringing down the line, and also enhanced use and auditing of CMP. Because before this, SCMP is just you have a document that be enough. But now you need to enhance the use of SCMP. What is SMP? SMP is Ship Energy Efficiency Management Plan, EEDI and Energy Efficiency Design Index. So we are used to this, all right, since 2013. But this is new. EEXI, Energy Efficiency of Existing Ships. That means all ships, okay, above 400 gross ton, running in international waters, must attain EEXI below a certain required standard. Yeah, so this is a big game changer in the sense that all ships are required to have EEXI now. And CII, the Carbon Intensity Index, above 5,000 gross tons, must monitor the Carbon Intensity Index. And we have such a graph like this one here. This is how to calculate EEXI, where in terms of carbon intensity, we can use AER, average annual ratio. And from here, the ships should be given rating of green, yellow, or red. So a ship should not be in the red. So we should make effort to become C, B, or A. So this is the thing. So I covered 5 topics. 5 topics here. 1, 2, 3, 4, 5. Now we go to the last topic, which is towards energy efficient low carbon ships. What are the ship designers, ship builders, and ship owners doing towards, if we want to maintain, to answer or stay within the current mandatory international rules? Okay, so let's see what's happening in energy efficient low carbon ships. Okay, 4 parts can be done. Number 1 will be in terms of design. So we can design low carbon ships. Number 2 will be in terms of augmented energy source, wind or solar. We can go also operational approach and also zero carbon fuel. I go very briefly on each one. So for design approach, we can do many things. We can optimize the block coefficient, for example, and we have some values here given by Watsila. Using hull air lubrication, using hull coating, whole hull coating, using contra-rotating propeller, waste heat recovery, and also to use larger ships. So these are some of the things. So I'll just share with you what's happening to the size of the ship. Yeah. So in the 2008, 14,000 TEU, well, you know, TEU, 24 equivalent unit of containers, is already the biggest ship in the world. But I just go very briefly what's happening throughout. This is in 2015 we go, this is 19,000 from 40,000, and this is 21,000. Okay, and finally this is the last one, I think, is already 24,000. So this is what you call as the economy of scale. The bigger the ship, the more efficient transport capacity is. So this is one way of doing it. So that's the design one. And then for the alternative or augmented energy source, people can use trying to use the kite, wind power, yeah, and also like this, wind power. They say 20% saving every year.
And solars.
And they use also solar power. So this India launched first Asia largest solar power RoPax ferry service. This is a solar diesel actually. It's not fully solar, but this one is fully solar. It's a ferry. Yeah, and also this one is also solar. This is very new, recent, September 28, 2022. Okay, so they have the Artemis there. Okay, and then the operational approach. Operational approach means only one slide for operational approach. You should know better. The cadets here, especially the deck officers, they can do many things to reduce the speed, reduce speed and so on. That can reduce fuel consumption. And finally, the zero carbon fuel. This is my last part, which is now people are looking at how to remove completely fossil fuel. That means the fuel that we use, either LNG or we say to be good, or the oil fuel or diesel fuel, oil and so on. So we are talking about biofuel, hydrogen, and also methane, methanol, and so on. So all these are being investigated now. Maybe Brain can look into this as well. And so this is, but there are a lot of challenges, particularly in terms of the logistics. How do we put hydrogen throughout from here to Europe, availability of this and so on. So it's not very easy. Okay, so I think this is I've covered all this. I'm just showing to you again my table content. Number 1 until number 7, number 6, I've covered all of them, and it's for me to conclude. Yeah, so we have shipping activities will continue with the increase of world trade, although it contributes only 3%. And the shipping community is doing its best in mitigating GHG. And then IMO is doing playing a vital role in this crusade. I call it a crusade, jihad. Basically, if you Malay here, we can say that we are jihad to reduce the GHG. And rules and regulations formulated by IMO are being enforced uniformly across the globe through port state control and flag state control. And finally, I've also shared with you the technologies that need to be developed to enable the ship to fulfill the requirements, and also the innovation that's required to reduce costs, which otherwise will be passed on to the consumers. The issue is mainly, if we talk about, for example, once we start to use hydrogen, for example, it's going to be expensive. The technology is still expensive. And if we have the EEXI, energy efficiency of existing ships, we have to limit the EEXI value. Then if we have a certain EEXI value, we need to, for example, reduce speed, we have to derating the engines and so on. So we will have problem in terms of that, and that will cost, that create more cost for the ship owners. I think our governments particularly need to look into how we can help the industry to survive within this industry, because we want to follow the IMO rule because it's good for the environment, but we don't want to negatively, adversely affect our shipping community or shipping industry. If you know, sustainability is not only environment. Sustainability, as mentioned by earlier speakers, will be 3. Yeah, number 1 will be the environment, number 2 will be the economy, and number 3 will be the social. So we cannot sacrifice economy for the sake of environment, and also we cannot go the other way around as well. Okay, thank you very much, Captain Indra and the audience. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, sir. You are 2 minutes earlier. I'm not interrupted you 5 minutes before it is terminated because you are entered to the conclusion, to the concluding remarks. However, in my observation, you are presented 7 items as the first one, GHG emission from ship, and then secondly, introduction of the IMO, especially for its instrument and enforcement. Thirdly, first mandatory regulation of IMO for mitigating GHG from shipping. But the challenge is the NOx, SOx, and PM 2.5, or particulate matters 2.5. And then fourth, goal of IMO and the initial IMO GHG strategies. The fifth, current mandatory international rules affecting ship for international trade. And then the sixth, toward energy efficient low carbon as design alternative augmented energy source for wind and solar system, operational approach, zero carbon fuel. So, sir, thank you very much indeed for reminding us about this important reference, especially in conjunction with the implementation of MARPOL Annex 6. Now we arrive to the fifth keynote speakers. It will be Dr. Yuan Chang Liu. Please be apologized if I'm not read your name correctly. Dr. Yuan Chang Liu is the assistant professor in autonomy at UCL, or University College London, United Kingdom, since 2018, and an international recognized expert in robotic with expertise in perception, planning, and control that enable mobile robot to achieve robust autonomy in complex physical environment. Dr. Liu received a Master of Science degree in Power System Engineering and PhD in Mechanical Engineering, both from UCL in 2011 and 2016, respectively. Dr. Liu has secured 9 research grants as PI and co-PI from prestigious funding agencies, including EU, Royal Society, and UKRI, and from 2017 to 2018, worked as the technology managers for one of the largest EPSRC-funded robotic research hub. It costs pound 8.6 million. Dr. Liu has over 60 high-impact publications with over 1,100 citations, H-index 15, including in prestigious robotic journals and conferences, and won 5 awards or prizes from IEEE, Society of Maritime Industries, and UK and Ireland Robotics and Autonomous System, or RAS Society. Dr. Liu research work have achieved global impact with 1 paper awarded the highly cited papers in Web of Science and 3 papers ranked top 2% globally in Scopus metric. Dr. Liu has extensive experience in conducting funded innovative research, which involve discovering novel technologies and promoting high-impact practical implication. In 2020, Dr. Liu was the PI of Aladdin project funded by Lloyd Register Foundation to successfully design a novel deep adversarial network for online fault or risk detections for autonomous system. In collaboration with National Oceanographic Center, the research outcome have been implemented onto several gliders to support long endurance operation in North Atlantic Ocean. In 2020, Dr. Liu was awarded a research grant from Royal Society to develop a new graph model-based ultra-efficient decision-making system for agile robots, and the research has led to several prizes, including the IEEE RAS UK and Ireland Section Poster Prize and the Championship for Marine Autonomy Challenge 2020. His presentation today entitled Advanced Marine Propulsion and Marine Autonomy. Dr. Liu, the time is yours.
Thank you very much. Thank you very much, Chair. I hope I can share my screen. Are you able to see the screen now?
Yes, very clear.
Okay. Thank you very much. So today I'm going to give my presentation talking about the advanced marine propulsion and marine autonomy research at UCL. And I'm going to give my presentation from actually 3 different perspectives. Firstly, I would like to introduce my research group, which is called the Marine Research Group. And I will be specifically talking about 2 major research works within our group. First of all is how we are undertaking the hybrid propulsion systems for the future low carbon shipping. And secondly, I'm going to talk about the marine autonomy research within our group. So our research group is called the Marine Research Group. It's actually one of the 4 research groups in the department. We also have the biomechanical, the energy, and materials research. We are offering various teaching activities at both the undergraduate level, master level, and also the short distance, the short courses. And we undertake the research mostly surrounding the maritime sectors, and we had a very good collaborations with industry to actually try to make sure the research is industrially focused as well. We have very strong international reputation and relationships. As far as I know, our research chair actually has one of the funding in collaboration with Indonesia, supported by British Council and Newton Fund. In the group, we currently have 8 professors, 8 and 5 lecturers, which is the assistant professors equivalent. And also we have 3 teaching fellows, and also our research is widely supported by researchers such as postdocs and PhDs. So the research activities within our group, as you can see from the list, is ranging from the very fundamental ship design or commercial or submarine design, all the way up to the very complex systems such as the computational methods for the ship design and the automation and robotics. And actually, one of the 2 pillars in our research group is actually the emissions and low carbon shipping. And so today I'm going to focus on these 2 areas within my talk. With regards to the low carbon shipping, we actually has just recently completed one of the largest research projects in the UK, which is about £5 million funded by UK Research Council. UCL is leading this research project, and in collaboration with other 5 universities within the UK, including Newcastle, Southampton, Manchester, Strathclyde, etc. We have received a very wide industry support, such as Lotus Register, Rolls-Royce, BMT, and Shell. The output of this research has been well communicated to different agencies and government policy makers, such as IMO, etc. IMO. So, one of the research activities within this project is actually how we can decarbonize in the shipping industry. We are, I think this is kind of very similar to the previous keynote speaker presentation, that for the global shipping, it actually accounts for about 2.2% of the greenhouse gas emissions, and we are globally governments are trying to reduce this greenhouse gas reduction emissions by 50%, and in together with the reduction of the NOx emissions and other emissions. So we're focusing on the coastal shipping. The reason is because about 25% emissions of the global commercial fleet is generated from the coastal shipping, and most of the shipping is actually ships are using small 4-stroke, medium or high-speed diesel engines, and which is all under a wide operating profile. And because most of them are operating at much smaller power requirements, which means that we can well integrate or develop a hybrid propulsion system, such as the fuel cell and battery hybrid propulsion systems, to support or actually replace the conventional propulsion system. This structure here is actually what we proposed system architecture. As you can see, we have the fuel cell together with the battery, and also we have the shore electricity to actually help to charge the batteries. And by using some converter or DC to DC or AC to DC converters, we can well use the generated electricity to support the propulsion systems and actually drive the ships. And one of the major scientific challenge here is actually how we can develop a very efficient energy management system to actually balance the energy coming from the fuel cell or energy coming from the batteries. So what we propose to do is actually to use in the state-of-the-art reinforcement learning algorithms to actually by knowing a operation profile from the expertise then we can apply this reinforcement learning algorithm to train a sort of algorithm system to learn the best or the optimized operations. So here are some results I would like to share with you. The first one is actually the ideal operation profile. We have the required power profile, and then we have the power source power, and this is the battery operation or operating profile. So these two figures here is actually generated by two different reinforcement learning algorithms. As we can see, the generated profile is actually quite similar to the optimized or ideal operation profile, which means that the algorithm is able to actually provide a very good energy management of this hybridized system. And so that's all about the very brief introduction to the low carbon shipping and the low carbon shipping technologies that we have developed. The second thing I would like to share with you is actually my major research areas, which is about the unmanned surface vessels or vehicles. So we call it also as the marine robotics. And there's two figures here we can see is two very famous platforms developed by this one of the by DSTL, which is the military of defense in the UK, and this is another platform developed by a company called L3SV. This is actually one of the largest commercial USV or ASV manufacturers in the world. And this platform is called the Seaworker 8. This is a very the long endurance surface vessel, which can support a non-stopping 7-day operations in the ocean, powered by a hybrid propulsion system. And in order to achieve the autonomous navigation for USVs, we propose to develop a autonomous navigation system, which is supported by, first of all, different types of sensors. For example, we have the GPS, IMU, or marine radar to actually provide the localization information and also the perception of the surrounding environment. And then in the middle, we have the decision-making and the planning system, where we can use the acquired sensing data to support generating different decisions. And then the generated decisions will be converted into waypoints to actually guide the movement of the USVs. And then the other problem that we are just recently quite focusing on is that we're trying to further advance the technology for small-sized marine robots, which means that we couldn't equip the robots or USVs or ships with a lot of different sensors due to the payload restrictions. And most predominantly used sensors is actually the visual systems or cameras. And compared with other types of sensors, such as the, for example, LiDAR systems or radar systems, the camera can provide very rich textual information, and it is a lightweight sensor, and also the power consumption of the cameras is relatively low as well. However, there are two major limitations for the cameras when we use this for the environment detection for USVs. One is that the environment, the performance of the camera will be highly limited by the environment. For example, if we if we encounter with a very hazy environment, as you can see from this picture here, then the camera system is not able to robustly pick up where the sky is, where the water is, where the obstacles are, which will largely compromise the performances. The other one is actually the reflections of the sunlight on the water surface. Again, if we can see from this pictures here, we can see due to the very strong sun reflections, then the water skyline is not very visibly to be detected, which will obviously affect the performance of the vessels. So the challenge here is how we can improve the camera systems actually to compensate this limitation generated by the different environments. So the research methods that we propose actually, again, we want to use the deep learning algorithms to actually help to solve these two limitations. So we develop a autoencoder and decoded architecture where we take the image information into these networks, and then the network will be outputting a segmented information for the surface vessels. And this is a video clip that I would like to share with you. So we have the input image, and then the network is able to convert it into a segmentation mask where the sky, water, and obstacles or land are well segmented. And then we can further apply some, for example, the water skyline detection algorithms to detect where the water skyline is, and also can use the object detection algorithms to detect the obstacles on the water surface. And based on this information, the USV is able to plan the trajectories afterwards. So that goes to the next research areas that we've working on with, which is called the path planning. So we need to plan the trajectory based on the required acquired environment information. Then we need to plan the trajectory from the starting point to the end point by avoiding any obstacles en route. So traditionally, we apply the method called the potential field, artificial potential field methods to generate this trajectory, as shown in this figure here. And then we apply it to the maritime domain by considering, for example, what the trajectory will be looking like if the environment has different the ocean currents, and also how the USV is able to travel by coordinating with different other vessels, and also how the USVs are able to moving around within the environment by avoiding other dynamic or moving ships. So this is all the research that have been undertaken around about 5 years ago. And most recently, what we're thinking is...
excuse me, sir, your time's 5 minutes remaining.
Okay, I've got 3 more slides. Thank you very much. So we are recently focusing on how we can further improve this research direction by developing a high-fidelity simulation environment. This is because most of the experiments can only be undertaken in the simulation environment, but most available simulation platforms, they couldn't well reflect the real dynamics and scenarios in the ocean. So we use the system called the robotic operating systems, where we can develop a very vivid model of the USVs by integrating the dynamics of the vessels, and then we can apply different controllers onto the platforms, as well as integrating the camera systems to actually provide a high-fidelity simulation environment. And then what we tested this environment by looking at a scenario which is the investigation of the offshore wind farms. So we have creating the simulation environment where we can see the wind turbines here, and we also have the USVs. As you can see, the simulation environment is actually to provide a very vivid reflection of how what will be happening in real environments, and we have the camera information be inputted into the system in real time, and this is planned trajectories, and also the real-time reflections of the control command. So that's all I would like to share with you today. Thank you very much, and I'm happy to take any questions if you have any. Thank you very much.
Thank you very much indeed. Thank you, sir, for your wise selection in wide range of subjects area, which is full of knowledge, and therefore you can offer the complex training topic in a very short period. If you don't mind, may I summarize your comprehensive presentation as follows? Firstly, the introduction of the UCL gave us a clear view that if we want to study either the undergraduate or graduate on robotic mechanical engineering, we know where to go. Thank you. And secondly, you explained briefly 2 out of 11 research activities, that is emission and low carbon shipping, and automation and robotic. The low carbon shipping, however, derived to decarbonizing shipping industry, either for global and coastal shipping. And then the third, the correlation of a ship as a system with transport demand and supply demand interaction and evolution, which derive into decarbonizing shipping industry and lead us to the energy management in hybrid marine propulsion system. And then the fourth, autonomous navigation system for unmanned surface vehicle using vision-based detection or computer vision technology, whereas the CCTV act as a human eyes and instruct the computer to respond as we want, which is similar with the advanced intelligent diagnostic and advanced intelligent maneuvering in a smart marine system. And then the fifth, path planning for unmanned surface vehicle, that similar with advanced intelligent routing in smart marine system and advanced data delivery in fleet operation solutions. Again, sir, thank you very much indeed for your important input to enrich our knowledge and for our review of curriculum for both deck and engine department. Now we arrive to the last keynote speakers. It will be Dr. Jung Chul Bai. I'm very sorry if I'm not pronounce your name correctly, sir. Dr. Jung is the president of Korea Marine Equipment Research Institute, Korea, or also known as KMOU, Korea Maritime and Ocean University, in 1986, and then got the ME, Marine Engineering, in 1992, and DE, Doctor in Engineering, in 1996 for Marine Communication at KMOU. He had been employed Saracom as a technical executive officer, as Director General from September 1988 until February 2006. He has experienced Korea Marine Equipment Research Institute, or KOMRI, as a managing director of Electric and Electronic Research Centers, Audit Department, and Management Planning, etc., from March 2006 until 2020. Now he is president of KOMRI, commencing from July 2020 until now. And then president the Korea Society of Ocean IT from July 2018 until now. Vice president of the Korea Society of Marine Engineering from January 2021 until now. Regained president of the Society of Naval Architects of Korea from July 2022 until now. The title of his presentation is Smart and Green Ships Equipment Technology in Korea. Sir, the time is yours.
Thank you. Can you hear me?
Yes, we can hear you clearly. Thank you.
Okay. Ladies and gentlemen, distinguished participants, good morning. I'm sorry, good afternoon. I am Jung Chul Bai, President of KOMRI, Korea Marine Equipment Research Institute. I am very delighted to join today's conference. Also, thanks Captain Indra for introducing me kindly. I will show my file. Okay, just a moment. Again.
Not yet.
Not yet? Okay, we try.
Yeah, share screen.
Okay?
Not yet. Yeah.
Okay.
Yeah. Now, please kindly enlarge your presentation with the presentation mode.
Sorry, but I use like this. Is it okay?
Yeah, that's okay.
Okay. Yeah. Today I will present with like this content, especially eco-friendly marine equipment according to the recent issues. If possible, if I have time, I want to approach a little deeply technical methods. Actually, yesterday I met Dr. Anthony Arif Priadi in Korea, in Korea Maritime and Ocean Universities. Maybe today he stayed in Mokpo in southeast area in Korea. Okay, I will start to my presentation. First slide is, as you know, is a global new shipbuilding market is the recovering from last year, and the first half of this year, new shipbuilding global order is the 21 billion CGT. The Korean shipbuilding company get the order 9.8 billion CGT. That means 45% market share. So Korea is really #1 shipbuilding country at the moment, as you know already. This figure is the show the IMO plan to reduce CO2 in marine field according to the International Carbon Emission Reduction Program. Already we know we call the IMO GHG emission reduction. We call. We can look at this slide. It make every new requirement. That means every year we have to develop a new marine equipment. I mean, for example, this is 2006. First time is emission control area is decided. We first time is already 15 years ago. That time is 28 years. We call this tier 1. After that time tier 2. Then 2016, that time tier 3. When I say this one, every year required new regulations. That means shipping companies are very difficult to adopt these new regulations. But otherwise, for example, this situation is very headache for shipping company, but it is another opportunity for the marine equipment manufacturer and shipbuilders. I mean, marine equipment manufacturer and the shipbuilders have a new chance for new business. So then we have to think about how to change the eco-ship. Then first time we have to consider the many technical issues of first stage, how to producing the alternative fuel. The next point is how to transport and supply the fuel like that. I mean, is to convert to green ships. That is not only simple technical methods. I mean, that is very complicated from using fuel to the use of power and propulsion systems. So we have to consider very wide range of technical methods. We can look this once, change the fuel. Now is 2022. As you know, recently we use almost of the oil fuel. That means bunker or diesel. But recently, slowly growing up to use LNG fuels. We forecasting 20-25 years, maybe a similar quantity to use conventional oil and LNG fuels. After that, over the 2030, that is revises. LNG use more large than conventional oils. After that, we think about the 2050s, then conventional oils cannot use almost 30% we will use LNG, 67% we will use zero carbon fuels, for example, hydrogen, ammonia, like that. This presentation shows IMO strategy on reduction of greenhouse gas emissions. In Korea, I'm sorry, this is a Korean word. In Korea, we made the law of acceleration of the development and the distribution of eco ships. That is regulation names. So that is include the target of the changing 15% eco ships. That means that now our country have more than 3,500 ships. I mean the coastal ships, government ships. Then our target is until 2030 years, we will change more than 50% from conventional ships to the eco-friendly ships. That means zero carbon ships. That is a government plan to change the eco-friendly ships. We have to think about then how to development of eco-friendly ships equipment. Actually, eco-friendly ship is consists of eco-friendly ships equipment. I mean, first time we have the development of eco-friendly equipment. After that, we can make eco-friendly ships. So I think four parts. First part is the technology. I mean that we have to development. Second one, after the development is some equipment, we have to test and verification and 2 and 3. Number 4, that is we have to make international standardization. That means we say that make standardization of a new domestic aquamarine equipment technology. Then means for marketing, we should need a type approval certificate. Also to reading international market continuously, have to make international standardization with our friendly method. That is a very important point for marketing, for international marketing. We have a plan. We have decided already plan to development, how to approach to eco-friendly marine equipment. So our government, my government means Ministry of the Trade and Industrial and Energy. That is the one of the ministry. Another ministry name is the Ministry of the Ocean and Fishery. Two ministries already decide to the development. Korea, we make some organizations. Korea Organization for the Innovative Eco-Friendly Ship Technology Development. Actually, my institute name is a committee. We have operation these special organizations. So these organizations will be operation until 2030. That means that is a 10 years project. Actually, we invest this long-term project more than $200 million for 10 years. That is a very big budget. So we have many tasks, main tasks like this, but later please read this. What is the main task of these organizations? This one is concept of the green ships technology. Actually, first time reduce the SOx. Also, we have to think about how to GHG reduction until 2050. Already, IMO decided is 50% instead of the 2008 years. Law and regulation revision about the greenhouse gas monitoring. So, for example, lastly, we have to use zero carbon fuels, but that is cannot change rapidly. That time we think about we have to use blended fuel. For example, LNG plus ammonia, like that. That is we call blended fuel or mixture fuel. We call. Also, we have to think about hybrid ships. That means electric propulsion ships is at the moment we cannot make big power. Normally less than 1 megawatt. Less than 1 megawatt means we cannot use big ships, ocean-going ships, just use coastal ships. So that intermediate time, we have to use a hybrid system. Later, I will explain a little more. What is the hybrid system? This one is actually we make to eco-friendly. We have to consider another techniques. That means it is not only change the fuel, but hybrid system using shaft generator. Shaft generator means we installed is a big motor parallelly using shaft generator. That time we can sometimes put the energy. In another case, get the energy from the shaft. So that is the same method of the hybrid car. So we think about use the hybrid ships using shaft generator system. That is one of the way how to make eco-friendly ships equipment. Also another way also we have that is just left to later. I will explain a little details. Hybrid propulsion existing in ships, existing internal combustion engine, just engine and generator separately. But future hybrid ships means engine plus battery system is same as the hybrid car. That is a main engine, that is a propulsion screw. We put the big motor or this motor also can use generator, can use as a generator. So that is we call hybrid system. Now we are thinking about coastal electric hybrid ships will be commercialized shortly, maybe 2 years later. But localization means in Korea, manufacturing of the key marine equipment is maybe about 3 years required. Lately, we have to scale up to use big ships. That is, it takes a more long time. So maybe 7 or 8 years later, we can use is big ships. Big ships, we think about almost 10 megawatt capacity. That is very big size. So every year we have to scale up to from small ship or to the big ships. This one is ammonia fuels. That is originally we use just the conventional oil. Lately we use ammonia fuel cell engine. This is now under development stage. We think about it 2 or 3 years later that you can use actual ships. That is another way. So we are also development of the energy reducer, high efficiency propeller.
Excuse
high
me, sir.
Efficiency propellers.
5 minutes to go.
Okay, thank you. Yeah, so we have many way of the technical method like this. This one is another we think about the how to equipment installation and verification. After the development, we have to need surely this process. So now we make this plan. Also, we have. Also, already I explained what is the importance of the international standardization. When we develop our own technology, then we have to make this international standardization using our method. That is, we have a way to get marketing, international marketing. So time is limited, so I will make some summarize. First time, we have to decide the development of items. What kind of items we have to develop for eco-friendly marine equipment. There is some complicate this slide, but you can look this one, ammonia engine and high voltage shaft generator and FGSS. FGSS means fuel gas supply system, ammonia fuel cell, convert and invert, fuel cell energy saving system, high pressure switchboard. Like this is we decide to development within 8 years. Also, we make the roadmap for the technology development. We make a 3 group. This is ammonia engine group, ammonia fuel cell group. This is a hybrid propulsion group. We decide the 3 groups and we make like this roadmap. After that, until 2031, we all complete this development and we will adopt real ships. That is our country plan. So that is a reference for you. I'm sorry, the time is limited. I cannot explain it more deeply, but I wanted to say in Korea is the leading country over the shipbuilding and the marine equipment. So I'm very happy to join this conference. Then more details, please contact to me this email address and telephone number. I'm sorry, time is limited. That's all over my presentation. Thank you very much.
Thank you very much, Dr. Jung Jilbai. Thank you very much for your very informative input on how the Comrie implement the smart and green technology in South of Korea, mainly concerning introduction of shipbuilding industry based on global shipping industry and IMO plan, with regards of law and master plan for developing eco-ship, plus IMO strategy on reduction of GHG emission, as well as concept and conversions of green ship technology. And then secondly, about the major strategy in the implementation of the master plan, and then eco-friendly marine equipment, which is at least consists of between 6 or 7 topic, as they are the use of shaft generator, if I'm not mistaken, and then the second, electric hybrid propulsion, and then the third, change the fuel, the fourth, waste heat recovery, and then the fifth, ammonia fuel or fuel cell, and then the seventh, something like hydrogen or propulsion, hydrogen carrier and propulsion. Again, thank you very much indeed for your very comprehensive presentation. This information will be very useful for us to review our curriculum for engineer officer, especially because this is not written in the IMO model course 704 for the engine officers operational level. Also, it is not in the IMO model course 702 for engineer officers managerial level. And perhaps we will include in the training of IGF code. So thank you very much for your kind presentation. Fine, ladies and gentlemen, although we are 20 minutes behind the schedule, now we arrive to the question and answer. Possibly there are not too many questions, but please, if you submit the question, would you kindly tell who will answer the questions? So your question is addressed to whom? And therefore we can convey to our invited keynote speaker. You may assist me.
Yes. Okay, Mr. Captain Indra. Now we have one question from Zoom meeting. Is from Mas Diana, University of Haluleo. The question to Mr. Captain Anthony. The question is, I just want to give some of ideas. Maybe the government always makes some introduction of toll out activity because many people doesn't know where, what, how to use, and finally activity of toll out looks like don't grow up. That's the questions.
Unfortunately, Mr. Anthony is now conducting the meeting in South of Korea. So we are very, very sorry. We will postpone, and perhaps the answer will be transmitted by email or something.
Okay.
Next question, perhaps.
We just have one question from a Zoom meeting now, but maybe we can give opportunity to all the participants here. So please raise your hand if you have questions to all keynote speakers. Okay, the first is 1, 2, and 3.
Maybe someone could give the, I have my free mic over here. You can use it anyway.
Thank you very much. Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
My question is for Dr. Yusuf of Brain.
Yusuf.
use of a brain. I'll be literally, frankly speak, why focusing on cable-based monitoring tsunami? Is it more cheaper than radio wave? You know me, yeah, because we also I think UDADIT also think the same. Why focusing on cable-based? Is it cheaper? I think it's more too much for us. As I know that next year we'll be focusing on the economically growth, since all people say that 2023 will be a recession all around the world, including Indonesia. So please do enlighten us why BRIN choosing the cable base to monitor tsunami all around Indonesian waters. Thank you. By the way, my name is Baeda. I'm next door with UDADIT in Saijo. Thank you.
Okay, thank you, sir. We have first questions for Mr. Yusuf Nur Wijayanto, PhD, National Research and Innovation Agency. And maybe
another question.
Another questions. Cadets from PIP Makassar.
Excuse me. Good afternoon, everyone.
Good afternoon.
So I'm a representative of Cadet PIP Makassar. I would like to ask for Dr. Yuan Chang Liu. For Dr. Yuan Chang Liu.
Yeah.
So in his presentation, he discussed about unmanned surface vehicle. He mentioned about unmanned surface vehicle, which is used for both military and civilians purpose. So if we discuss this from the economical side one, which one is more cheaper? I mean, like, will it be cost cheaper or more expensive in the side of the usage for the latter, sir? So if we try to compare this with main surface vehicle or ships with crew and manual system, sir. Thank you.
Okay, thank you. Well, another questions? Okay. Oh.
Thank you. I want to raise my question to BRIN. Bapak BRIN. BRIN, yeah.
BRIN. Okay.
You just talk mostly on the phase of development of the research and development of the what you are doing in research. I just wanted to know what's the implementation now in the market, which usually, I mean, mostly used now or available in the market. All the application in research from BRIN that already available in the market with regard to the navigation at sea or the shipping. Thank you.
Thank you, sir. Well, we have 3 questions already. So the first and the third questions to Mr. Yusuf Nur Wijayanto, PhD, National Research and Innovation Agency. Time is yours, sir.
Thank you very much. You can hear me? Can you hear me?
Yes, we can hear you.
Okay.
Clearly.
Thank you. Thank you very much for the question. It's very interesting. 2 questions with the very interesting. Okay, I will try to answer the first question. Yeah, actually, if we compare with the price of the sensing on the tsunami sensing with the we can see using the remote sensing satellite, something like that. Also, we can see it, and also another we can use the camera on the beach to to show the increase of the water or something like that, we can see also. However, this is the another possibility. I say, and this is another possibility. And here we propose the new method to get the very early signal from the deep ocean. This is the one target. If we correspond to the economical, we will use the existing optical fiber for communications. Two, we ask to the provider, please add some optical fiber for the sensing. Give me permission to use your network to the sensing. The sensing is not for the tsunami. The sensing can be used for the many things. We can, how to say, know all of the mystery of the underwater, undersea, our sea. This is very important for us. So we can make the future economy for the undersea. The fish and the climate, we can see in the our sea. Our sea is very, very unique. This is very important for the world. Yeah, this is because Indonesian is very, very important for the world. Yeah, this is our focus. So this is maybe in the future, we can combine the optical fiber and then the many sensors in the underwater. So we can make the monitoring in the underwater. We use the camera for the fishing, for the monitoring the pollutant, and maybe the gas, oil, we can monitoring in there. Okay, maybe that's my answer. If we compare with the price, it's very expensive. I see, very expensive. But we will use for the multiple purpose in here. Yeah, that's all for my first question. And the second question, regarding regarding the product of the BRIN. Yeah, you know, the BRIN is the new agency in Indonesia. Before the BRIN, we have the LIPI, you know, the BPPT, you know, the LAPAN, you know, the BATAN, the nuclear, and then the avionic, and then the technology, and then the scientific. Actually, we have the many product. However, some product is how to say, some if we want to the dissemination of the product, we need the company. And here we need the company to make the go to the market. Several products already done, already published in the market. As you know, in the in the pandemic era, we product the ventilator, something like that, maybe, and also we have the another product for the, if you remember, is N219, yeah, N219 is our product also. Is also used for the commercial in the market, and PDDE already used, and another product is also coming. However, in here, in today's presentation is maybe in the for future product. And also in the ICE, in the today presentation, I also mentioned the ICE is already also in the market. However, in this is some problem coming because some standardization. You know, maybe in the market, if we want to sell the product, we need the, how to say, the standard, and maybe we need the standardization, and the mitra, our partners still try to achieve the standard. So if possible, so on will be in the market, so on. Okay, maybe that's all my answer. Thank you very much.
Okay, thank you. Give applause to Mr. Yusuf Nurwijayanto, PhD. Hope can answer the questions. Well, the next questions to Mr. Dr. Yuan Chang Liu from University College London, United Kingdom.
Thank you. So the question is about whether it's a cost-effective way to deploy unmanned surface vessels. I think this is an open question. First of all, we need to categorize the unmanned ships into different, according to their size. If we're talking about the small-sized vessels or unmanned surface vessels, then probably the answer is yes, because most likely we're going to deploy USVs in a remote and very dangerous, risky areas. And so it will be very, very costly or very expensive to deploy humans or other human operators in these areas. However, if we're talking about large ships like cargo ships, tank ships, which is kind of the future trend, if we're talking about autonomous shipping, then I wouldn't say at the moment it will be a cheaper way, because even though we can replace the human operators with, for example, advanced machine computer algorithms, but it still requires the training of personnel who are capable or who is able to understand this technology, and eventually you need to have some pilots to actually have an overview of the whole operations, even though all ships are autonomous. And the training of this personnel or human operators will be very expensive due to the high technology involved. So if we look at it from a overall perspective, maybe not, but I'm quite optimistic about this, especially if we're talking about what will be happening in 10 years or 15 years later. Probably the cost will be reduced. Yeah. So I hope that answers your question.
I think.
Okay.
Closing.
Thank you.
Please.
Okay, thank you, Mr. Dr. Yuan Chang Liu from University College London, United Kingdom. Hope can answer your questions. Well, ladies and gentlemen, we have one question from Zoom meeting. This question to Mr. Jung Chul Bai from Korea Marine Equipment Research Institute, Korea. The question is, now many ships already using fuel oil low sulfur on board. Other ships still using FO 380 CST and 180 CST. Is there any new issue or regulation, for example, VLCC or ULCC ship for using low sulfur fuel or for emission? Well, Mr. Jung Chul Bai, time is yours.
Yeah, thank you very much. Good questions. Actually, sulfur required is already I show you the that today they like this is a long time ago already required these ones. Reduce the sulfur, we have to equip the Sakuraba. That is additional equipment. That is for the last stage of the chimney. That means the Sakuraba is very big size and very expensive. So when we equip the Sakuraba, at the moment is a very good result. Why? The oil price is very high at the moment. But we cannot guess that price is continuously high or going down or more high. We don't know. But anyway, we have to prepare the another alternative oils. So I explained we have to develop this using alternative oils. For example, mixing oil, or mixing oil means LNG plus ammonia, mixing oils. Then it reduce the SOx and reduce the PM. That means that we can adapt to requirement of the IMO requirement. So we are institute. That means that we have to development of the equipment. Then we have to make us very widely preparing new equipment. So the user, I mean the shipping company, use any ones we can supply, this one or this one. So that is my answer. Is it okay?
Okay, thank you, Mr. Jung Chul Bai from Korea Marine Equipment Research Institute, Korea. Hope can answer your questions. Well, maybe next is closing statement from all invited speakers. So please, Captain Indra Priyatna, to lead.
Ladies and gentlemen, Please be apologized for not answering all of your important questions today. And I believe there is still a lot of questions that will be forwarded, but since the time is limited, we have to terminate this conference. And then thank you very much for your patience and your kind attention within 3.5 hours continuously. I believe that the previous presentation derived from so many disciplines with various research methodology that will be very useful for the future curriculum development on maritime education and training in Indonesia, especially in Makassar Merchant Marine Polytechnic. On the other hand, the presentation from the 6 keynote speakers provided the big pictures of innovation in maritime industry that could contribute the development of human resource as well as the improvement of role of Indonesian sea transportation in the global supply chain. Before the completion of this conference, we would like to ask all of the invited speakers to convey your 1-minute closing statement. It will be start by Mr. Stefanus. Mr. Stefanus, please over your 1-minute closing remarks. Is this working?
Okay. Yes.
Okay.
Thank you, Captain Indra. The closing statement from DGST that the achievement of sustainable transportation cannot be done alone by one institution only. It can only be achieved by mutual coordination among associated ministry and all entities, such as government and non-government organizations, stakeholders, academies, or even among countries globally. Because the goals of transportation sustainability is also beneficiary for future generation, our child, our grandchild, or even for forevermore. Thank you.
Thank you very much indeed. It's very short anyway. The secondly, it's for Mr. Yusuf Nur Wijayanto, PhD. Mr. Yusuf, time is yours.
Thank you very much for the closing remarks. On the future technology, it's very important. So maybe we need to research and innovation for the future, our better life. So in the maritime application and then shipping application is very important. Maybe that's all my question. Thank you.
Thank you, Mr. Yusuf Nur Wijayanto. Next will be from Professor Dr. Omar bin Yaakob. Professors, time is yours.
Okay, thank you very much. I would like to thank again the Polytechnic Ilmu Pelayaran for inviting me. I'm sure many things being shared by myself and also the rest of the speakers will be very useful not only for the participants today, but as Captain Indra said, it's for the development of the curriculum. I would like to suggest very well that the curriculum for future, not only in Makassar Poly, but also in the rest of the maritime institutes, must take into account these issues that we raise here, especially about low carbon shipping, in terms of design, development, building, and finally operation of the ships, because we need to contribute to this low carbon shipping. So the students and later the graduates and seafarers later need to understand that this is a very important contribution that we are doing to save our mother Earth. So I think that's important. And the second point is more about collaboration. Thank you very much, because this is part of the collaboration internationally. I think in the region as well, we can collaborate more in doing certain projects and what we call it, unifying some of the rules between Malaysia, Indonesia, and ASEAN, for example. That's a good way to go. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Mr. Professor, for your kind advice. Next will be closing remark from Dr. Yuan Chang Liu. Doctor, time is yours.
Thank you very much. First of all, I would like to thank the kind invitation from the panel and from the conference. It's my great pleasure to give this keynote, this presentation to you. And I actually want to say or address the how the collaboration between between the UK and Indonesia and other countries, because I'm surprised that the topic that covered in today's presentation have a lot of overlapping. For example, we didn't communicate with each other before this conference, but by listening to other keynote speakers, I'm surprised that we are all focusing on, for example, low carbon shipping, how we can create more environment friendly by reducing the emissions, and also the importance of the autonomy in maritime industries. So I believe there's a lot of opportunities, and hope that more collaboration can be undertaken in the future. Thank you very much.
Thank you very much, Dr. Liu, for your important closing remarks. The last but not least, it will be the remarks from Dr. Jung Julbei. Dr. Jung, the time is yours.
Yes. Thank you very much. Today I get a really good time and fruitful time. Also, I'm sorry, I didn't know about this conference's main focus. If I have time, if I have a chance to join again, then I will preparing more excellent materials for you, for audience. And as you know, in Korea is really very high-level country for the shipbuilding and manufacturing marine equipment. Recently, our government policy is to how to hand over to another country. For example, say Indonesia is a very biggest ocean country. So I want, if we have a chance to meeting to cooperation development project with Indonesia. That is my needs. Okay, thank you very much. Today I was joined this conference. Thank you.
Thank you very much indeed for your kind offer. We will report to our boss. Thank you very much. Ladies and gentlemen, this conference is reaching to the end, and therefore allow me to invite Ms. Winda to continue with the closing session. Once again, thank you for your kind attention and cooperation. Ms. Winda, the time is yours.
Okay, ladies and gentlemen, once again give applause to Mr. Captain Indra Priyatna, who has conducted us during the session, and also thanks to all the keynote invited speakers for today. Well, ladies and gentlemen, before we close our meeting in today's conference, we would like to appreciate all the invited speakers by providing certificates of appreciation, because Mr. Stefanus Risdianto come here join with us directly. So Mr. Stefanus will be represent all the invited speakers to receive the certificates of appreciation from Polytechnic Ilmu Pelayaran Makassar. And the certificate of appreciation will be delivered by Director of Polytechnic Ilmu Pelayaran Makassar. We kindly invite Mr. Captain Sukirno, Master Magister on Transportation Management, Master Marine. Time is yours, sir. Well, certificate of appreciation to Mr. Stefanus Risdianto, and also we also appreciate our moderator for today. So we also give certificate of appreciation to Mr. Captain Indra Priyatna.
Oh, terima kasih, Pak. Terima kasih.
Okay, thank you. Thank you, Mr. Captain Sukirno, Director of Polytechnic Ilmu Pelayaran Makassar. And we want to inform to all invited speakers who have joined via Zoom meeting, we will send the certificates via email or electronic mail. So we will send to all the invited speaker certificate of appreciation because already joined with us in this ICMaD 2022. Well, ladies and gentlemen, we have finished all agendas for the conference today. I am Winda Anggraini. Would you like to say thanks to all officers, Maritime Affairs, keynote and invited speaker, our moderator, and also the all participants who have joined and stay for this conference. And also thanks to be part for our anniversary. See you on the next conference, ICMaD 2023. Good afternoon and goodbye.
Udah. Ya Pak, terima kasih. Kenapa? Kenapa?
Well, we kindly invite all the participants of ICMaD 2022 to join with us on stage to take a picture. Once again, we kindly invite all the participants of ICMaD 2022. Please come with us to take a picture on the stage. Well, we inform to all the participants of ICMaD 2022. So all the participants can join with us on the stage to photo session in this afternoon.
Tes, mohon izin saya arahkan sedikit. Mbak Winda join aja Mbak Winda sekalian. Bapak Ibu bisa ditambah lagi, di atas juga bisa, di panggung. Biar kelihatan ya, di panggung. Silakan Bapak Ibu. Taruna juga silakan. Mbak Winda. Ya. Silakan Bapak Ibu. Ya, di sela-sela. Di atas terus. Sampai di mana? Di atas lagi, Pak. Aduh, ada teleponnya. Bisa. Tes. Ayo enggak kelihatan.